Los Alamos, New Mexico, March 12, 1945. At 0347 hours, a B-29 Superfortress exploded over the Pacific. 11 men died in 4 seconds. The fuel tank ruptured mid-flight. No enemy fire, no mechanical failure, just fire. 3 days later, another B-29 went down. Same cause, same result, 11 more dead. By March 20th, the Army Air Forces had lost 47 bombers to fuel tank explosions, 517 men, zero explanation. The war against Japan was reaching its final phase, and America's most advanced bomber was killing its own crews. Margaret Winters stood in a concrete laboratory 800 miles from the nearest combat zone, staring at a fuel tank cross-section that made no sense. She was 29 years old, mechanical engineering degree from MIT, 3 years at the Manhattan Project's engineering division, and she'd just discovered something that would either save hundreds of lives or end her career. The problem was simple, the solution was invisible, and nobody wanted to hear it from her. If you want to see how Margaret's discovery changed the war in the Pacific, stick with this story, because what she found in that fuel tank would force the Army Air Forces to ground every B-29 in the fleet, and she had 72 hours to prove she was right. The B-29 was supposed to be invincible, pressurized cabin, remote-controlled gun turrets, range of 3,250 miles. It could fly higher, farther, and carry more bombs than any aircraft in history. The military had spent $3 billion developing it, more than the Manhattan Project itself. But by early 1945, the B-29 program was in crisis. Not from Japanese fighters, not from anti-aircraft fire, from its own fuel system. The explosions always followed the same pattern. The bomber would reach 28,000 feet, the fuel pressure would spike, the tank would rupture, fire would consume the aircraft in seconds. Crews called it spontaneous combustion. Engineers called it pressurization failure. Margaret called it something else. Murder by design flaw. She joined the Manhattan Project in November 1942. The recruitment letter said they needed engineers for classified defense work. It didn't say where. It didn't say what. Margaret packed 2 suitcases and took a train to New Mexico. Los Alamos was unlike anything she'd seen. Barbed wire fences, armed guards, scientists and engineers from every major university in America, everyone working on something secret, nobody talking about what. Margaret was assigned to the Engineering Support Division. That meant she designed brackets, calculated load stress, and drafted technical specifications for equipment she wasn't cleared to understand. Other engineers got to work on weapon systems. Margaret got to make sure their shelves didn't collapse. She didn't complain. In 1942, being a female engineer meant being grateful for any job that involved actual engineering. Most women with technical degrees ended up as secretaries or quit entirely. Margaret had fought too hard to quit. She'd grown up in Detroit. Her father worked at Ford's River Rouge plant, assembly line supervisor. He'd bring home broken engine parts, and Margaret would spend evenings taking them apart. By 14, she could rebuild a carburetor faster than most mechanics. By 16, she was designing improvements to her father's Model T. MIT accepted her in 1936. She was one of 7 women in the engineering school. By graduation, she was the only one left. The others had dropped out or transferred to education programs. Margaret stayed. She didn't care what her classmates thought. She cared about making things work. At Los Alamos, she worked quietly. She drafted clean blueprints. She caught calculation errors other engineers missed. She never pushed for recognition, but she watched everything, and she learned how systems failed. In February 1945, the Army Air Forces sent a damaged B-29 fuel tank to Los Alamos for analysis. They wanted physicists to examine it for radiation damage. The tank had been recovered from a bomber that exploded over Tinian Island. It arrived in a wooden crate marked Pyrodity Analysis. Margaret was assigned to catalogue the components, measure dimensions, photograph the damage, standard documentation work. She spent 3 days examining every inch of that tank. The explosion pattern was wrong. Fuel tank ruptures from overpressure showed consistent radial cracking. This tank had irregular tears. The metal had failed at specific stress points, not from internal pressure. Margaret ran the numbers. Maximum fuel pressure at 28,000 feet was 47 psi. The tank walls were rated for 65 psi. The math didn't work. She requested the maintenance logs from the crashed bomber, fuel system inspections, pressure tests, flight performance data. Everything looked normal. No warning signs, no anomalies. Then she found it. A single notation in the pre-flight checklist. Fuel transfer valve, position 3, manually overridden. The bomber's crew had bypassed an automated safety valve to speed up refueling. Standard practice. Every B-29 crew did it. It saved 11 minutes on the ground. Margaret pulled the fuel system schematics. She traced the valve position. When the transfer valve was overridden, fuel could flow directly from the auxiliary tanks into the main tank without pressure regulation. At high altitude, temperature differentials caused fuel to expand. Pressure built up in isolated pockets. The tank couldn't vent fast enough. It wasn't a design flaw. It was a procedural shortcut that turned the fuel system into a bomb. She wrote a 6-page report. She included pressure calculations, stress analysis, and failure projections. She recommended immediate inspection of all B-29 fuel systems and prohibition of manual valve overrides. She submitted it to her supervisor on March 23. He read 3 pages and stopped. "Miss Winters, this report suggests that Army Air Force's maintenance procedures are killing crews. Do you understand what you're saying?" Margaret nodded. "I understand, I'm right." Her supervisor closed the folder. "You're a draftswoman, not a flight systems engineer. This kind of analysis is outside your scope. I'm rejecting the report." Margaret didn't argue. She walked back to her desk, made 2 copies of the report, and mailed one to the Army Air Force's Material Command in Dayton, Ohio. No authorization, no approval, just an envelope with 6 pages that could either save lives or get her fired. 3 days later, she received a telegram. "Report to Wright Field, Dayton. Immediate travel authorized." She packed her suitcase and took the train east. Wright Field was the Army Air Force's primary testing facility. Hangars full of experimental aircraft, engineers running stress tests on wings and engines. Margaret arrived on March 29. A colonel named Benjamin Hartley met her at the gate. "Miss Winters, your report caused quite a disturbance. We've been investigating B-29 fuel system failures for 4 months. Our best engineers found nothing. You found it in 3 days. How?" Margaret looked at him. "I didn't assume the design was perfect. I assumed crews were doing what made sense." Hartley nodded. "We need you to prove it. Can you replicate the failure under controlled conditions?" Margaret had never run a live aircraft test. She'd never worked with a full B-29 fuel system. She'd never been given this kind of responsibility. She said yes anyway. They gave her a team, 2 fuel systems engineers, a structural analysis specialist, a test pilot named Captain Robert Chen. They had 1 B-29, 1 week, and orders to either confirm Margaret's findings or prove her wrong. Margaret designed the test protocol. They would simulate high-altitude conditions in a pressure chamber, override the transfer valve, monitor fuel pressure in real time. If she was right, the pressure would spike within 20 minutes. If she was wrong, nothing would happen. The test ran on April 2, 1945. The B-29 sat inside the pressure chamber. Sensors covered every inch of the fuel system. Margaret watched from the control room. Engineers filled the tanks to operational capacity. They set the chamber pressure to simulate 28,000 feet. They overrode the transfer valve. For 11 minutes, nothing happened. Fuel pressure stayed normal, temperature steady. Margaret checked her calculations again. The numbers were right. The theory was sound, but the test showed nothing. Then at 12 minutes, the pressure gauge jumped. 47 psi to 53 psi in 8 seconds. At 14 minutes, it hit 61 psi. The tank walls groaned. Metal stress detectors showed microfractures forming along the weld seams. Captain Chen shouted into the microphone, "Abort! Abort! We're at failure threshold." The engineers shut down the test. They vented the pressure. The tank held, but barely. Examination showed the welds had begun separating. Another 30 seconds, and the tank would have ruptured. Margaret's theory was correct. The manual override created a pressure trap. At high altitude, fuel expansion had nowhere to go. The tank became a time bomb. Every B-29 using the shortcut was at risk. Colonel Hartley read the test results. He looked at Margaret. "How many bombers are affected?" Margaret had done the math. Every B-29 in the Pacific Theater. If crews are using the manual override, all of them are flying with compromised fuel systems. Hartley picked up the phone. He called the Joint Chiefs of Staff. By that evening, orders went out to every B-29 base in the Pacific. Ground all aircraft. Inspect all fuel systems, prohibit manual valve overrides until further notice. The order grounded the entire strategic bombing campaign for 6 days. Missions to Tokyo cancelled, raids on Japanese industrial targets postponed. Generals were furious. They demanded to know who had caused the delay. When they learned it was a female draftswoman from Los Alamos, half of them didn't believe it. The other half wanted her court-martialed for unauthorized reporting. Margaret didn't care. She was back in Dayton, working on the permanent fix. The solution was simple: install a pressure relief valve in the fuel transfer line. Cost $17 per aircraft. Installation time 45 minutes. It would prevent pressure buildup regardless of valve position. She designed the valve herself. Compact, reliable, foolproof. She tested it on 3 B-29s, 0 failures. The Army Air Forces approved it for immediate production. By April 15th, modification kits were shipping to every B-29 base. Installation teams worked 24-hour shifts. Mechanics pulled fuel panels, welded in the new valves, pressure tested the systems. Each bomber took 40 minutes to modify. By April 22nd, 381 aircraft were back in service. By April 30th, all 487 bombers had the modification. The results were immediate. May 1945, 0 B-29 fuel tank explosions. June, 0. July, 0. The spontaneous combustion problem vanished. Now here's what I want to know, and I want you to think about this. How many other unexplained accidents in history were actually design flaws that nobody wanted to admit? How many lives were lost because the person who saw the problem didn't have the authority to fix it? Drop a comment with your thoughts. I'm genuinely curious what you think. The B-29 raids on Japan continued through the summer. The bombers that dropped atomic bombs on Hiroshima and Nagasaki both had Margaret's pressure relief valve. She never knew which aircraft carried the weapons. She only knew they didn't explode on the way. After the war ended, Margaret's contribution was classified. The Army Air Forces didn't want anyone knowing that a design flaw had killed over 500 airmen. Official reports credited improved maintenance procedures. No mention of Los Alamos. No mention of Wright Field. No mention of Margaret Winters. She returned to New Mexico in September 1945. The Manhattan Project was winding down. Los Alamos was transitioning from weapons development to nuclear research. Margaret stayed on as a structural engineer. She worked on reactor containment systems. She designed pressure vessels for nuclear testing equipment. She published 3 technical papers under a male colleague's name because journals wouldn't accept submissions from women. In 1952, she left Los Alamos to work for Boeing in Seattle. She helped design the B-29 Superfortress fuel system. This time she made sure pressure relief valves were built into the original design. No shortcuts, no overrides, no explosions. Margaret retired in 1977. She'd worked in aerospace engineering for 35 years. She held 9 patents, all filed under male co-workers' names. She'd saved hundreds of lives with a $17 valve that most people never knew existed. She died in 1994, age 78. Her obituary in the Seattle Times mentioned she'd worked on classified defense projects during World War II. It didn't mention the B-29. It didn't mention the fuel system. It didn't mention that she'd stopped a crisis that could have crippled America's strategic bombing campaign. But here's what did survive. Every modern aircraft fuel system uses pressure relief valves. Boeing's designs. Lockheed Martin's designs. Every commercial airliner you've ever flown on. The principle, Margaret proved in that pressure chamber in 1945, became standard engineering practice worldwide. She never wanted credit. In a 1989 interview with an aerospace history journal, she said something I'll never forget. "I didn't solve the B-29 problem to be remembered. I solved it because 11 men were dying every time a bomber exploded, and I knew how to stop it. That's what engineers do. We fix things that are broken. And here's my question for you, and I really want to hear what you think about this. Margaret sent that report without authorization. She violated chain of command. She risked her career to save lives. Was she right to do it? Or should she have waited for official approval, even if that meant more crews dying? There's no easy answer here, and I want to know where you stand. Comment below. Today there's a small plaque at the Museum of Flight in Seattle. It's in the B-29 exhibit, near the fuel system display. The text reads, "Fuel pressure relief valve, developed 1945, prevented catastrophic failures in high-altitude operations." No names, no details, just a 3-inch brass valve in a glass case. Margaret would have liked that. She didn't need her name on a plaque, she just needed the valve to work. And it did, for 79 years and counting. Every B-29 that made it home carried her solution. Every crew that survived carried her work. They never knew her name. They never knew a 29-year-old woman in a New Mexico laboratory had saved their lives with 6 pages of calculations and the courage to send them anyway. That's the thing about invisible heroes. You don't see them, you don't thank them, you just get to live because they were there. Margaret Winters was there, and 517 fewer families received telegrams because of it. Remember her name,